Okay, so go ahead and get started. For those of you that I don't know, my name is Shannon Jocelyn. I'm an IGG PhD student. I work over in the animal science department. I work on Delta Smelt, and I'm affiliated with the DIB lab through means of trainings and teaching, and just because they're good people. But so we're going to go through, this says Intro to Compute, or tips and tricks for working on farm, specifically submitting jobs to Slurm. Taylor and Louise, feel free to interrupt me with any things to add in. This isn't a comprehensive, like how to interact with Slurm or how to function on the farm. It's just a couple of things that are that I've found to be informative over my grad school career and use of the farm, and you might too. So any burning questions before we start? No, okay. So we'll just dive into what exactly is a cluster. And a cluster can be thought of as a group of computers which work together to allow you to log on to one computer or a head node and use resources to perform memory-intensive functions. So think of yourself as, down a little bit. If you think of yourself here interacting on what now looks like ancient computers, you connect to the internet, and through the internet you can connect to the farm, which is connect to one individual computer there. You can think of it as an individual computer, or the head node, the login node, and from this login node we can then access a bunch of other computers. So effectively through working on our computer, we have access to a bunch of other computers that have a lot more memory and resources, although we're always interacting on our computer. And so the way that clusters work is we can carry out memory-intensive functions by submitting jobs to the top level of computers there, and we can use multiple computers at once, or we can use we can like call on a really big computer that has a lot more memory and RAM than our computer in order to get memory intensive jobs done. And the way that we do this is through the use of job schedulers, the ones that the farm uses specifically, and Barbera uses as well. I think all of the clusters on campus, they all use Slurm, which I don't actually know what it stands for. I just think of Futurama whenever I think of Slurm. But what happens is we're a user here, and we submit a job to that we would like to run. So maybe we want to align our sequence files to a reference genome, and we submit this script to the batch server. This batch server then puts in the series of batch jobs that they have to the job scheduler, and that factors in various group resources and requested resources that you're asking for from Slurm, like time, the amount of memory that you're using for the job, the number of nodes that you'd like, or which partition you're submitting to. So if you have if you'd really like a job done quickly, you can submit it to high partition, or if it's something that you don't really care if it gets done immediately versus wait in the queue for a while, you can submit it on a lower partition, so it's lower priority than some of your other jobs. And it determines which jobs to run and in what order. So the way that time factors into that is Slurm might take a job that you put a time limit of 8 minutes on, and that might go through even though it's the same priority as something that's going to take 8 days, because it's only going to take 8 minutes. And the way that matters is because we all have, if we're interacting, how many of you are interacting on a farm already? Okay, so most of you. So if we're interacting on farm, we have access to a set of resources. So maybe your PI has bought into a certain amount of resources. You might have access to big mem nodes, or you might not. But the reason that matters is you might submit a high priority job, and if everyone in your group is using resources, then and will be using resources for 8 days. If you have an 8-minute job that's going to take place, it could either go after those 8 days, or the way that Slurm functions, and Louise or Taylor, correct me if I'm wrong, again, the way that Slurm functions is it says, oh, okay, this will take 8 minutes, and a group from, or a computer that belongs to this other group is not being used, so I'm gonna allow you to use those resources for 8 minutes because no one in that group is using resources. They have more resources. So it kind of, it matters how much time you take to carry out things. Yeah.
How do you know how much time to put in?
That's that. So the best answer that I've come up with, which isn't a very satisfying answer, is trial and error or by talking with other people. It depends on the amount of compute that you assign to that job as well. If it can be be paralyzed, then that could shrink down the amount of time that you're using, but then it takes up other resources in other places, right? So you're inflating the amount that you need at that moment, but not the length. And so it depends on what your PI has access to, and just what you've assigned. So I usually will I'll try to overestimate. There's not, I believe on the farm, there's not time limit. It's like 150 days or something for the time. Is it? Okay. There's not really a time limit that you can have. So you're only inhibiting yourself if other people are using resources and you ask it for 100 days. Then.
Sorry, I thought you said hours.
Oh.
Sure about days.
Oh, okay. Yeah. Yeah. But basically, I just overestimate, and then I go down from there. And you can overestimate, and then once you've run it once, you can see, oh, the last time I ran this on sequence data files that were the same size, it took about this long. I'm going to give it an extra couple hours, or something.
It's super long job, throw in information, but you can tell it's about to run out. You can help at CSC, whatever it is, to help what's associated with the form, and they can extend the job.
Oh, okay.
I think I've done that twice, but only on things that were running for 2 weeks, and it was clearly just needed 2 more hours to finish. 2 more weeks. Okay. I think judgment do it 12 hours before it expires, so they have a little bit longer. Okay.
Yeah, they usually get back to you within a day. And I've actually severely underestimated things. I mean, I thought this was going to take 4 days. Looks like it's going to take 14 days.
Mm-hmm.
And they can extend it by that as well. That's not a good strategy. That's not a good strategy at all when you're working with other people and you want to maintain positive relationships between those people. But if you get into a crunch, you can extend it in that way. And I think if you were to do that often, the farm would probably be stop doing this after a while. Yeah. They are people behind them, so they can notice what happens when you're using resources and whatnot. So yeah, we submit to the job scheduler, and it's in the case of the farm, that job scheduler is Slurm. And then basically what the job scheduler does is allows you to execute the code contained within that script that you've submitted to the scheduler. And from there, you can have three outputs. One is a standard out. You'll always get a standard out with your Slurm scripts. The next is a standard error. This is optional. You can tell Slurm that you'd like a standard error file. They're really great for troubleshooting when your code may not have run. And then you get your output files if your job has output files. Not all jobs have output files, but if yours does, that's what you'll get. And so the standard out file is the file that it's basically, so when you're interacting on the farm and you type ls, and you'd see all of the files and directories within the directory that you're in. That's what the standard out contains, is the readouts from any of your commands. So anything that would flash in front of your eyes if you were doing it at the command line yourself. Whereas the standard error kind of gives you more error messages. Yeah, so here are some of the resources that the job scheduler evaluates. So partition and priority, and we'll go into each one of these. How much of the group's resources are already being used, so that's how much your PI has bought into and how much resources you have. Some groups have big mem nodes that they can access, other ones do not. The requested amount of wall time and the requested amount of resources. So that's memory and also the number of CPUs that you're going to be using.
What do you distinguish between memory and CPUs for me?
Louise might be better at distinguishing between the two. Memory and CPU.
So CPUs is what's doing, like what's calculating stuff, and memory is where you're storing the stuff that's being calculated. So like a lot of times you might be using something that can't use a lot of CPUs, like you can only use one CPU at a time. But you need to use a lot of memory to store the data for what you do. So like you need 20 data. Okay. And if you're using tools that support using more than one CPU, then you can use like 24 CPU, 20 gigs of data. Ideally, you would run 24 times faster than just one CPU.
And that's where you would get into maybe your time would be shorter, but you have to make sure that you have access to all those resources. And you can get yourself in a crunch if other people are also using those resources. You might just, if you request 16 CPUs and, there's only 12 open in your group, then your job's going to stay in the queue. Yeah. Any other questions? Okay, so there are two main ways that you can request resources from Slurm. The first is running an interactive session with srun, which is like immediately nice, right? Because basically what you're doing is you're taking yourself from this computer here, and you're logging onto the head node, and instead of interacting on the head node, you're then requesting one of these computers up here, and you're interacting on that computer up there that you've requested. Which is great, but also has some fatal flaws. So none of the commands that you run when you're in an interactive session are going to be saved. So that means if you wanted to go and recreate an analysis, you're not going to be able to know, oh yeah, so 2 weeks ago I was in an srun session and I mined all my sequence files. It was great, and I did a series of steps, but I can't really remember what I did. None of that will be saved. So you might have your output files, but you won't know the steps that you took to get those output files. So it's dangerous in that way. What it is really good for is testing things out, just to see if certain commands work. So you can try out commands there, but I wouldn't ever carry out an experiment in srun. And so to request and launch a basic interactive session, you would use srun and then --time, a certain amount of time that you're saying you're going to be using that computer for, and then --pty/bin/bash, and that's saying that you would like an interactive bash session. You can do /bin/r, and that would give you an interactive R session with the resources that you request. So you can request a certain amount of memory and CPUs in your session as well. But another thing to look out for is that Slurm will terminate the session at this time. So at 2 hours, it doesn't matter how far you are along in what you're doing, it'll automatically terminate it. So it's another good reason for not carrying out analyses using srun. So the one, and you can request more in different resources with memory, CPU, and an R session. So the way that hopefully 99% of your interactions on the farm will go is through sbatch, the sbatch command, and this submits batch job scripts, which are also just known as job scripts. And they contain a shebang at the beginning, which is hash, exclamation point / bin / bash. I don't know exactly what the exclamation point is doing before it. Either of you guys know? It's just the syntax. And so it's at that. Those are contained at the beginning of each of the scripts, and they're submitted to Slurm. And so let's create some ourselves. So just a show of hands, how many of you guys have created batch scripts before? Okay, so a lot of you. So this will be, a lot of this will be not new to you, but so. You guys log on to the farm. Can you guys see that in the back? Yeah. Yeah. Okay. So, okay, we're gonna make this script hello world. And we can copy and paste the following. So this is our shebang here. And then we have a series of, these are a series of shell commands. So we have echo hello world, and then it's gonna sleep for a minute, and then it's print out the date. So just as a, before we get into this, I just will show you that you can do all of these commands can be done just at the command line. So echo hello world, produce this hello world here. Sleeping for a minute means that this is going to take a minute for that command to run. And then it'll print out the date at the end of that, which we can wait for. Any questions in the meantime? They're just two different text editors. So the Nano is a lot more basic, and then VI, like VI, it takes, it's not really that intuitive to exit out of. Whereas when you open up Nano, it tells you at the bottom how to get out of it. So it's a preference thing. Yeah. Okay. So these commands slept for a minute and then printed out the date. So it printed out Wednesday, February 12th, blah, blah, blah. So all of those commands are common shell commands. And so let's put this into a script. So nano and then we can exit this and we save it. Okay, and then if we do sbatch hello world.sh and hit enter, we see that our batch job submission failed because the requested time limit is invalid. So Slurm needs to know, it needs some things. It needs to know how long you expect your job to take. So an upper limit on the amount of time that your job will take. It doesn't mean that it will run for the entirety of that time. It just means that it knows what to expect, so it knows how to put you in the queue. So we run this with the time. Then we have submitted batch job 182000741. And so a few things to think about when we're submitting jobs is we use a number of different flags to kind of hone in on exactly what we would like to use when we submit our batch script, and this can help ourselves out if we're doing really memory intensive things. where we need a lot of resources, because Slurm won't necessarily allocate all of the resources that it could if you just if you submit a job using only a time flag. I don't know what the default is off the top of my head, but I know it submits to a medium partition. One of the things that you could submit to is a partition or a priority, and the farm has the following partitions. So it has parallel nodes, high, medium, and low, and these are 24 nodes with 64 CPUs and 256 gigabytes of RAM, and also 95 nodes with 32 CPUs and 64 gigabytes of RAM. You don't need to memorize these, and just put them there so that you have quick access to look at them again when you're asking for resources. I will say that when you ask for memory, you can't use all of the memory on a particular CPU. At least I haven't been able to, because there's some that this is how it was described to me. This is a biologist's description of computer science, which I apologize to these. But basically, there are some things that need to be done on the computer that you're not going to notice and you can't allocate resources to, but Slurm needs to do in order to have your job run. And so you can't allocate all of the resources to your job. So you could do 250 gigabytes of RAM maybe. You'll get a really cryptic message if it fails because of memory, and so it's just something to be wary of. And then there are also big mem nodes, so BMH, BMN, BML, big mem H, big mem M, big mem L, and these are high, medium, and low partitions of big mem nodes. The BN letter, those are newer ones that Farm has acquired recently. The big mem letter are older ones. And so you're doing a couple things with your -P flag. You're both indicating how big of a computer you would like and how immediate you would like your job to be run. So big mem L job, that job can start running and it can be interrupted by something that is higher priority. So big mem H. Big mem M, I believe, can also be interrupted. It can be suspended, yeah. It can be suspended by a higher priority job. And so something to think about when you're asking for resources is, let's say that you were gonna run 300 jobs. You wouldn't want all of those jobs to be high priority because then no one else in your lab group can sneak in a quick job. So if you're gonna run 300 jobs, then you might want to go with a lower priority. They'll still get done. Usually, depending on how your lab functions, if there are a lot of computational people, or if there aren't, usually it still gets done pretty fast. It's like be nice to the people around you because you're all sharing resources. And so unless you're doing something that is quick and it can be done, be done fairly quickly, and you just need it to test something. Maybe don't use the high priority. Maybe use medium or low. We default to medium in my lab. I'm not sure why, but it's worthwhile to have a discussion in your lab group if multiple people are using resources for what qualifies as being a high priority job versus a medium or low priority job. The Div Lab had that discussion this week because with more number of individuals that come on to working on the farm, means the more organized that you have to be, right? Because if you have 50 users and everyone is submitting to high memory, the high priority status, then it's just, what if there is something that's actually high priority? Things to think about. There's no one right way to do it. It's just something to be wary of. Any questions? Okay, so other flags that are that prove to be important is the memory required to run our job. So that's specific to, if you look up above, you can't have more memory than the computer has, right? So you can't have any more memory than the node has that that you want to run it on. So if you request more, I don't know if Farm will or Slurm will, I don't know if your job will fail or if it'll just stay in the queue or if you won't be able to submit it, but just do yourself a favor and go test it out and just always stay within the confines of whatever you're submitting to. And then some little tricks are we can have Slurm mail us updates about our jobs. So let's say we had one of those jobs where it was going to take 7 days and we wanted to know when it ended. We can have Slurm email when the job begins, when it ends, if it fails, or all of the above. So Slurm will email you, job failed, or job began. You do that with the flag stash that mail user, enter your email in, and then you specify the type of mail that you would like. So in this case, or all. You could just have Slurm email you when things begin, or just when things end. And then you can also give specific job names to your jobs. So this is helpful. We'll see when we run SQ. It allows you to have identifiers associated with your job, so you can know, oh, my alignment file has taken 3 hours. It's been going for 3 hours, but my Busco hasn't started yet. So, or my Busco job hasn't started yet. So it's a good way to monitor where things are at. And then you can also name the files that Slurm generates as output and error files. So Slurm will automatically generate an output file. It needs something to write the output to, so it just automatically does that. If you don't give it to it, it will be denoted by Slurm and then a series of numbers and then .out. But we can use these names to our advantage, so we can name them whatever we would want. .out. The .out is just a convention that we associate with the output file. You could name it .whatever, and it would come up as .whatever. But it makes it easier if you name it .out and .error. And so you can, let's say that you're running an alignment, and you could say, oh, okay, name this align to 10x ref.out versus align to packbio.out. You can compare the outputs or have two different files for those outputs. So those are a lot of flags. And if we were to write it all out on the command line, it would look something like this, which is a big line, a big command all at once. And then we wouldn't have any way to record that that's what we did. I mean, we could put it in Notebook, but then we'd have to transfer between the two, between our Notebook and what we wrote in the command line. So there's a better way to do this, and that's we can submit those batch jobs with all of these parameters inside of the batch scripts. So here we have that same script that we ran before, the echo hello world. This one says sleep 10 minutes because humans are prone to errors, and then the date. And it has all of the SBatch, it has all of the parameters that I would like to submit with my job. So notice that still on the first line we have the shebang, and then lines 3 through this line, 10 or 15, has these SBatch parameters. And so what this does is it tells Slurm everything that we told it in the command in that one long command before, except this time it's saved in a script. So in this script, We have that we want to be mailed. We would like all of the mail. We give the job a name. We call it Hello World. Just as a note, you can't have your job have infinite amount of characters. If it's 8 characters is the limit on Slurm. So this is over 8 characters. It'll just chop off where 8 characters are. The 8th character is located. So this would be Hello World would be the job name, but we want on the SQ, right? Okay, yeah. Okay, so it'll still have the job name, but when you go to SQ, when you go to look at the status of your job, it'll only show the first 8 letters. So. And then we have an error file that we called Hello World, and then an output file that we called Hello World. And then there's this J%, and what the J% is denoting, the first one is just a J, but the %J is, Slurm will attach the job number associated to that. So remember when we submitted our job, here we had an associated job ID number that will print to our output file. So that means that for each time that we run that script, we have a unique error and unique output file. And then I say I'd like a computer and one node, and I would like 1 gigabyte of memory. Allow me 11 minutes, and I can submit this to the load partition. So I'm not using up very many resources. I gave myself a little extra time because I knew it's going to sleep for 10 minutes, but there's other functions that have to happen around that. Any questions? Okay. And you would have to replace this email with your actual email address. It also does not have to be ucdavis.edu. Yeah. Oh, that would be terrible. You should. No, don't. But yeah. Is there a reason you wanted the job number? Yeah, because when let's say that something happens with your job, and it's like you don't really even understand what's happening with the job. Something is going wrong. It's supposed to work, and maybe you need to email the farm. You can email them the job ID number, and it just helps them, and it also helps to like if you're running multiple. Sorry.
I always put the job number there because like if you're rerunning something or debugging, you can find out like what's the right size for and stuff. Because it has the job name there, like you always keep all the outputs and the error messages from what you run without having to modify the file all the time. Like, hey, hello world 1 output.
Yeah, I do that often. Yeah, and sometimes I'll even go back to an error file that was like, maybe 3 error files back because I'll want something, or output files from 3 back because I'll want something out of it. Yeah, so they can add up quickly. You can always make a Slurm directory where they all go, but you have them all there, and put the Slurm outputs there. I've seen that done. So we can monitor our jobs, or let's actually copy this into our file. Okay, so I'm actually going to delete this line because I don't want it to email me. Oops. Okay, so now if I look at this file, I see that my script contains all of my job parameters that I would like, as well as the shell commands that I'd like to run at the end. And if I submit this job, I only have to use sbatch and then hello world. It's submitted with batch job ID, and I can look at the I can look at what jobs are currently being run on the farm using SQ. So if we type in SQ, we see a bunch of jobs here. We just really fly by because a lot of people are on the farm and using the farm. So this is a list of all of the jobs that are currently in the queue for Slurm. So if we go back, go to the top here, that's all of the jobs that are listed here, but Slurm is handling as the job scheduler. So we just basically printed this list of all of the jobs in the queue. And so you can look at just your jobs if you'd like. And so you can type in your username. So you can type SQ-U, SE Jocelyn is my username. And I see that I have this job in the queue here. And it gives me a few pieces of information. It gives me the job ID, partition that I submitted to. This is the job name. So this is why I was confused that I thought that, oh, it cuts it off at 8 characters, but that's just what shows in this SQ here. It actually still has the full job name associated. The status is pending. It hasn't spent any time. It hasn't been run yet, so it's not proceeding forward. Your job, when you submit, it might be going already. It's probably just that my lab is using resources, or the actual reason is listed over here. So nodes required for job are down, drained, or reserved for jobs in higher priority partitions. So I don't have access to any of the nodes yet. So that will change. And then it tells you the number of nodes you requested in CPU and the minimum memory associated with that job. And so if you didn't know, let's say that you're on a different cluster and for some reason you didn't know what your username was, you can always type "who am I?" and that will give you your username, which is handy. Or if someone was on your computer and logged on to the farm, and that would be weird, but anyways, you can always check your username or who you are. And you can also look at the amount of resources that your group is using. So we can type SQ-A and then the name of our group. So the name of my lab's group is Miller MR Group. And this will show you all of the jobs that your group is currently running. So we have we just discovered that my lab group, which is over in animal science, and the Bib lab have shared users despite not sharing any of our actual grad students or postdocs. So yeah. Anyways, so this will show you all of the users that are in your group and have submitted jobs to Slurm. They can either be going or in the queue. It's quite a long list in my lab group. It might not necessarily be so long in yours. And if you don't know what group you're in, because they can be named anything, you can type groups, and then you see which groups you're associated with. So I'm associated with Miller and R. You might have multiple groups that you're associated with if you're in multiple labs and they both have resources on the farm.
that happens when I'm on Barbera. So then you can choose which group to submit to. And we can also check the status of particular partitions. So we saw, remember when I ran this, nodes required for job are down, drained, or reserved for higher priority partitions. So here in my lab group, I can see that my lab mate Will has a lot of jobs running that are higher priority than me. So his jobs are going to run. My job, which is low priority, is not. So we can look at exactly what's going on with the low priority partitions by typing sq -p low, and you can see that the only person who has submitted to a low partition is me there, and it's just that the nodes that I'm asking for are currently being taken up by someone else in my lab group. And so we can also cancel our jobs. We don't have to email the help desk to cancel jobs. And the way that we do that is by using scancel and then the job ID. So here, my job ID is 182.0.1167, and I can type scancel job ID, and then if I were to look at the jobs that are currently in the queue for me, I no longer have a job in that queue, in Slurm's queue. So each group only has so much space on the cluster, and memory can be bought, but it's always good practice to compress and delete files as you go through analyses. We generate a lot of intermediate files in our analyses, and you might not always need those, and they can take up space for your group. And one way to look at how much space your group has is through using this df command. So we can type df-h, and the h is please make the amount of space human readable. So instead of a really long number, it's going to say 32 gigabytes. Too many bases and bytes. And then I'm going to grep for my name here. You can your username. And then you can hit enter. And you can see that of this -export-s SE Jocelyn, there's 22 terabytes of space and 21 is being taken up. There's 70 gigs that is free. So essentially we're using 100% of our memory here. This is a weird part of the farm where I'm actually not in my lab group's group. I'm a part of some other randomly assigned export 6 place when it comes to this memory. And my lab group actually has 59 terabytes of memory. So it's some weird part of the farm where. Yeah, that's what I mean. Okay. Yeah, so if this becomes an issue, which it has on occasions for me, and it just keeps compressing things and hoping that it will be, you can email the help desk and say, hey, here's that I'm part of some other group. My memory is like part of some other group. Can you switch me over to my actual lab group? And if I were to look for my lab group here, I can see that, if someone is a part of the Miller lab group, we actually have 56 terabytes of data, and we're all using about 50. Huh? Oh yeah, this one here is not actually part of the. No, I know. Okay. Yeah, they're part of the.
Moved on.
Moved on, but not moving on.
Yeah. Well. Oh yeah. Actually. But yeah. People stay on the farm for as long as they don't get deleted from the farm unless you explicitly ask for their stuff to be deleted. So we have a lot of people who have moved on from our labs. So any questions as far as checking in on how much space you have access to? So I should say that even though my group has, this has, 28 terabytes of space, I can't immediately use that unless I store it in specific directories. So I would have, if I needed to use more space, I would need to email the farm help desk in order to allow me access in my home directory to that amount of space. And so we can also look at how much any given directory is taking up. I'm going to go into the directory for this just because I have a lot of files and it takes a while. So we can look at how much space is being taken up. Go back to this command with this du command. And this flag is saying only tell me how much space. How do I put this? Basically, it will list out every single directory and how much space is in each directory. And this -D0 flag is saying, I don't care how many directories are under me. I just want to know if all of the amount of space that's under me without printing out a long list of all of the directories. And please make it human readable. At least if a command does say please, it would there. But so 560K, whereas just to get a sense of what that command looks like without the -D flag, it still gives me 560K at the end of the long list, but then it goes into each directory. How much space is each directory. Yeah, so nodes versus CPUs versus tasks. Basically, a node is a physical box that connects memory systems. This is just some syntax that connects memory systems with extension cards and CPU cores. And then, I wrote this for Barbara, I apologize. But yeah, on Barbara, you can only request one node or else your job will fail. And then a CPU core is an independent computing unit that can access a certain number of CPU threads, with the threads having independent input streams, but sharing total course memory, which is more complicated. Basically, it just says that there are threads contained within a CPU, and there are multiple CPUs within a node, and there's an incomplete tasks.
I like to try to think about your laptop. That your laptop could be a node that has 2 cores.
Mm-hmm.
And you can run tests.
Yeah. Yeah, so if we think about each one of the nodes having multiple cores or CPUs, and then you have access to multiple nodes on the farm. And each one of these orange boxes would be using multiple threads within those boxes.
So the orange boxes one box one thread.
No, not necessarily. So one orange box is one CPU, but there are multiple threads on your CPU.
So it's just a little multiple. It's just a little
Multiple. Yeah, and that's pretty much all that I have. Hopefully gathered a little bit more on the farm, but yeah, thanks for coming. Any questions?
Okay.